Now we want to take a look at how we find the determinant of a 3 by 3 matrix. There's a couple different ways in which we could go about that, as you can see, one of which is the diagonal method and the other is the cofactor method. I'm only just going to show here the diagonal method. So the way this is going to work is that if we are seeking to find the determinant of a matrix that is a 3 by 3, just like you see with the example matrix A right here, and that would be the same thing, right, using the straight bar notation. The way we'll find this is you actually need to kind of copy the first and the second columns of your 3 by 3 matrix. So A, D, G, and then B, E, H, but you don't need to copy the third column. And then, since it's called the diagonal method, you'll do like diagonals similar to how we did the 2 by 2 matrix. So when we did the 2 by 2 matrix and we found the determinant, we started with the main diagonal, and then we subtracted the product of the other diagonal. And so we'll kind of basically do the same thing here. It's just a little bit more work. So this right here, of course, would be considered the main diagonal, the one that swipes from the top left corner down to the bottom right. But we actually need all 3 diagonals that fits 3 elements inside of the diagonal, like you see right there. And what we'll want to do with all of them is we're going to want to take the product of the elements that are in the same diagonal as each other, separately though. So those products there, and then add those 3 products together with one another. So we're going to get a total from all of that, so I'm just going to kind of put parentheses to signify that. And then we'll do the other diagonal, so that would be like the other diagonal, right, going from the top right corner down to the bottom left corner. We do have, of course, 3 diagonals that fit 3 elements in that direction. So you'll basically do the same sort of thing. We're going to take C times E times G from that diagonal, and A times F times H, and B times D times I, and add that all together. You're going to get a total of all of that stuff there. So I'm just going to kind of put that in parentheses. And then just like we did with the 2 by 2 determinants, you'll subtract. So you'll kind of get your red total number, and then you'll subtract the blue total number from that. And so whatever that amounts out to be, you're going to get a final just number answer, and that's the determinant of that matrix. So let's see how that actually works with actual numbers. So we'll do so right down here with matrix R, and ask us to just find the determinant of the matrix. So we're trying to find the determinant of matrix R. So it is a 3 by 3 matrix, so based on what I was showing you earlier, you're going to have to copy the elements in the first column and then copy the elements that are in the second column there. So what you'll need to do is you'll need to start with the main diagonals, so those 3 diagonals right there. So I'm going to multiply together -2 with -3 with -6. So your product there is going to give you -36 for that number. And then I'll multiply 5 times 5 times -5, which is -125. And then -4 times 0 times 5. So since you're multiplying with a 0 in there, then you actually just get a product of 0. So those numbers, they all get added up together to give you a total kind of red number. So I'll just put brackets around that to signify that. So we're going to then subtract whatever total we get from adding these products that will be in the bluish color. So we'll use the diagonals that are right there in the blue. So one of our diagonals there is going to be -5 times -3 times -4. That equals -60. And then 5 times 5 times -2 equals -50. And then -6 times 0 times 5 equals 0. And we add those things all together. So if we then just kind of simplify a little bit, so first of all, starting by adding those 3 red numbers together, the total of those 3 red numbers is going to be -161. And then from that, we're going to subtract whatever total we get from the blue numbers there, which would be -110. So it does turn out that we are subtracting a negative right here. So when we then basically add 110 to -161, then we actually get -51. So that would give you the determinant of matrix R there, using that diagonal method for finding the determinant of a 3 by 3 matrix.